Machinery. Its power enables us to do things that we could never hope to do on our own. But there's a price to pay for this added productivity, because the more powerful and capable a piece of equipment is, the greater the danger it can pose to the people who use it. The hazards are very real. Roughly 15,000 machine-related accidents happen every year. They not only cause severe injuries, such as amputations, lacerations, crushing, and abrasions, they result in hundreds of fatalities as well. Yet most of these incidents can be prevented by machine guards and other safety devices. Machine guards are designed to keep you clear of mechanical danger zones and protect you from hazards like sparks, flying particles, kickbacks, and moving appendages. In this program, we'll take a closer look at the safeguards and work practices you need to use to work safely with this type of equipment. To help us understand the potential hazards of working with powered equipment, we need to start by looking at the different ways a machine can move. All machinery operates using a combination of three basic motions: rotation, reciprocation, moving back and forth, and transverse motion, moving in a straight line. These movements can also be combined to produce what is known as articulated motion. This can be especially dangerous because articulated motion makes it hard to predict which way a machine's parts will move. This is why machine guarding is often used to keep workers a safe distance away from robotic equipment. Computer-controlled machine movement can be very complex and very hazardous. There are three areas where a machine's moving parts can create potential hazards. Within the drivetrain itself, the moving parts that power the machine. At the machine's perimeter, the area around a machine where a worker could be injured by things like flying debris and swinging arms. And at the points of operation, where the machine's mechanical energy is used to cut, bend, move, or otherwise process materials. These are the areas that we need to pay particular attention to when we are around any powered equipment. Knowing that working around powered machines can be hazardous, what can we do to protect ourselves from them? That's where safety guards and safe work practices come into play. Let's take a look at two of the most frequently used types of machine guards. Fixed guards are the oldest and simplest type of machine guard. They include devices such as wire cages, clear plastic shields, or metal covers, which create permanent protective barriers. Drivetrains are almost always protected by fixed guards. Often the guards are built into a machine's housing to fully enclose the drivetrain's moving parts. Fixed guards are sometimes used around a machine's perimeters and at points of operation as well. However, since fixed guards are permanent, they must be positioned where they will not interfere with a worker's ability to access or operate the machine. In situations where fixed guards don't work well, interlock guards are often used. These guards use an electronic sensor that will not permit a machine to run unless the guard is in place. This provides workers with complete protection, while at the same time enabling safe access to all of the areas in and around the machine. When an interlock guard is opened, the sensor trips a relay switch that shuts off the machine's power. When the guard is closed, power is restored and the machine can once again be operated. While the two most frequently used types of guards, fixed and interlock, can greatly reduce the number of accidents around machines, drivetrains, and perimeters, other measures are often required to prevent accidents at points of operation. Accidents are common at these points because workers are often only inches away from a machine's moving parts. So it's extremely important to use machine guards at these locations. But at the same time, the guards cannot interfere with having someone operate the machine. For this reason, adjustable and self-adjusting guards are frequently used at points of operation. Adjustable guards can be moved by the machine operators themselves to suit their needs, such as when they have to work on objects of different shapes and sizes. Self-adjusting guards move automatically as material makes its way through a machine. Because of the way that they work, these types of guards must be inspected before each use, as well as every time there is a change in a machine setup. It's particularly important to make sure that the guards are adjusted properly, so that materials of various sizes can pass through without binding or kicking back. Additionally, adjustable and self-adjusting guards must never leave gaps or openings that are large enough for any body part to fit through. There are some situations where any type of guard can interfere with a worker's ability to run a machine. This is when safety devices should be employed. They can protect workers in several different ways. Light curtains are the most common safety device. These photoelectric systems use beams of fluorescent or infrared light to create invisible barriers around a machine's perimeter and in front of its points of operation. If someone breaks one of these barriers, a relay switch is tripped and the machine's power is cut off. By reflecting the light beams onto a series of mirrors, a curtain of protection can be created around a machine's perimeter. This keeps workers from getting close to any part of the machine that is hazardous, while allowing for a clear view of all operations. At points of operation, light curtains are often set up so that raw materials that are being fed to the machine will not trigger a shutdown. But if a light curtain permits a finger, hand, or other body part to pass through it without shutting the machine down, it is not set up properly and must be adjusted before someone gets hurt. It is essential that any machine that has light curtains installed comes to a complete stop immediately after the curtain is tripped, because a worker can still be severely injured by equipment that is grinding to a halt. For this reason, a machine that is protected by a light curtain must have its stopping time checked periodically by a qualified technician using special testing devices. If the machine is not stopping quickly enough, simple adjustments to the light curtain or the machine's braking mechanisms will usually fix the problem. Pressure sensing devices are another type of guard that is used to protect workers by stopping a machine's movements. There are two types of pressure-sensitive devices, trips and mats. Both are positioned around machines to keep workers from entering hazardous areas. Pressure-sensitive trips usually use wire cables as safety lines. If a worker touches one of these lines, it triggers a switch that stops the machine. In order for trips to be effective, the cables must be taut and set so that they will stop the machine at the slightest pressure. Because the cables can cover a wide area, pressure-sensitive trips are ideal for covering long distances, such as next to conveyor belts. By routing the cables through eyelets, trips can also be used to protect unusually shaped machine perimeters. Pressure-sensitive mats are another device frequently used to protect irregularly shaped machine areas, and because they are movable, they provide more flexibility than trips. These mats have weight-triggered sensors in them. In most cases, when someone steps on the mat, indicating that they are too close, a relay switch immediately cuts the power and stops the machine. But pressure-sensitive mats can also be set up to shut the machine down if the operator steps off of them. Used this way, they protect workers by forcing them to remain in a safe position while they operate the machine. Whichever way pressure-sensitive mats are used, they must be located directly in front of the areas where workers would be putting themselves in danger. And as with light curtains and trips, if there is any doubt about whether a machine is shutting down quickly enough, the machine and mat must be checked by a qualified technician. While each type of device we've discussed can be used by itself, in many cases there will be several types of guards and devices on a single machine. Using multiple devices is particularly important when any single device does not completely protect workers from all of a machine's hazards. For instance, An electrical spot welding machine might have a transparent guard to prevent the operator from being hit by sparks or metal fragments. A pressure-sensitive mat that allows the equipment to function only when the operator is standing clear of its moving parts. And fixed guards to prevent unauthorized persons from getting too close to the machine's high-voltage power source. Many safety devices protect all parts of the body, but there are other devices that have been designed to specifically protect the hands. These are used on machines where workers are directly exposed to hand and finger injuries. The simplest way to protect a worker's hands is to make sure that they are out of danger before a machine can start. Two hand controls accomplish this by requiring the machine operator to push two separate buttons at the same time in order to activate the machine. This keeps their hands safely on the controls and away from moving parts. On some machines, a drop probe device can be used to allow workers to safely hold materials at a point of operation. A drop probe drops to a predetermined spot an instant before a machine starts. If the drop probe falls freely, the machine begins its movement. But if it hits a worker's hand or some other obstacle, the machine will not start up. One drawback of drop probe devices is that while they can keep a machine from starting, they cannot stop a machine that is already in operation. For this reason, they must only be used on machines that perform a single, rapid movement each time they're activated, such as small riveters. Restrain and pullback devices are another type of hand protector. Unlike other guards and devices, they are attached to the workers that they protect. Restrain devices use short straps or cables that are attached to an operator's wrists. These protect the worker by preventing their hands from extending into the point of operation of the machine that they're using. Pullback devices give machine operators unrestricted access to a point of operation between machine movements, but will pull their hands back if they are too close to the point of operation when the machine starts moving. Unfortunately, even if a machine has had guards or safety devices installed on it at one time, that doesn't always mean that it is still safe to work with. So when you're around powered machinery, it's essential to follow safe work practices at all times. Since many accidents occur on machines that have had their safety guards and devices damaged, altered, or even removed, it is important to check them and never operate a machine unless its guarding is in place and operating correctly. Keeping your work area clean and free of tools, materials, and debris is essential as well. Any of these could fall into your machine, hit moving parts, and become projectiles. It's also important to wear personal protective equipment, such as safety glasses and face shields, to protect yourself from sparks and flying material that may make their way past a machine's guards. And you should never use a machine if you are sick, tired, or having trouble concentrating. Your full attention is required to avoid accidents. Another thing you need to be careful about is how you dress. Loose clothing, long hair, and jewelry can slip past a safety guard, get wrapped in moving parts, and pull you into the machinery. So wear tight-fitting clothing whenever possible. Make sure to tuck in shirts and button your sleeves. Keep your hair back and always remove jewelry. Wedding bands and other rings particularly cause problems because it's easy to forget to take them off. Most importantly, maintain a healthy respect for the machinery you work with. Many serious accidents happen to experienced people because they become complacent and decide that they can get away with dangerous shortcuts. Being safe on the job depends on more than government regulations and industry standards. It depends on everyone being conscious of the hazards they may encounter and using common sense. That's especially important when we're talking about machine guards and safety devices. Let's review. Be aware of the hazards that are created by the machinery you work with, and use machine guards and safety devices to protect yourself. Inspect guards and devices to make sure they are free of damage and functioning correctly. Never remove a machine guard or safety device. Make sure that they have been installed correctly and are adjusted properly. Wear appropriate personal protective equipment, such as safety glasses and face shields, whenever you are near machinery. And don't wear items such as loose clothing or jewelry that could get caught in a machine's moving parts. Powered equipment can pose real hazards, but machine guards, safety devices, and safe work practices can help protect you so that you can both increase your productivity and work more safely every day.